So now we're going to look at a few examples of multiplying and dividing polynomials. When you multiply polynomials, the key here is to distribute. Anything that's ever in front of parentheses is going to need to be distributed. And the reason is, like with order of operations, we always do parentheses first. So if I could, I would evaluate this parenthesis here. I would do w plus 6, but those are not like terms. I can't do w plus 6. They don't combine. So instead, we'll distribute whatever's in front to both of the terms inside the parentheses. We're multiplying here because it was written right up next to it. So what is negative 4w times another w? That would be negative 4w squared. Then negative 4w times 6, the negative 4 times 6 is negative 24, and then there was a w hanging around. So that's my final answer. If there were any like terms, I would combine them, but w squared and w are not like terms. Let's try another one, and you should pause and try this on your own first. Since this 3 is in front of the parentheses, I'll distribute it. 3 times 2 is 6m, and 3 times negative n is negative 3n. Again, nothing to combine, so that's it. All right, on this one, we get even a little more crazy. We've got 2 different terms directly in front of this polynomial. So not only do I need to distribute the 2, I also need to distribute the x to both of these terms. By the end, you should have 4 things written down, and it helps me to kind of draw out the arcs as I go. So x times 5x is 5x squared. X times negative 3 is negative 3x. 2 times 5x makes 10x. And 2 times negative 3 makes negative 6. Again, see how I have 4 things and I followed those 4 arcs? I distributed the x and I distributed the 2. Some people call this FOIL. You don't need to know that, but if you've heard FOIL, that stands for first, outer, inner, last, and it helps you remember all 4 of those things to multiply. All right, to finish this up, I do have a couple like terms. Negative 3x plus 10x makes 7x, but the rest will stay, the negative 6, the 5x squared. So that's my final answer. All right, let's try a few division problems. When you are dividing polynomials, let's think about fractions for a second. Like if I had 1/5 plus 2/5, what would that be? I think we all know that would be 3/5, but how did we get there? We got there by combining 1 plus 2 all over that 5. The denominator stayed the same. We combined the 2 numerators. We could do the reverse as well. If I had 1 plus 2 over 5, I could split it up as 1 over 5 plus 2 over 5. That's what this was. So the same thing happens in algebra. You can always split up a numerator over the same denominator. What I mean by that is I could split this up into 45 plus 20y and put both of them over 5. The reason that's helpful is because now I can simplify a little bit. 45 divided by 5 is 9. 20 divided by 5 is, plus sign. 20 divided by 5 is 4, and then there's a y there. So that's my final answer. It doesn't always simplify like that, but sometimes it does. Let's try this one. Again, I could split all of these terms up over that denominator. And maybe you could do this without writing it out, and that's fine. But 9a over 3, negative 3b over 3, and 12 over 3. because now I can simplify a little bit. 9 over 3 is 3a. 3 over 3 just cancels out. It makes a 1, and we don't need to write that 1, so it's just minus b. And 12 over 3 is 4. That's my final answer on that one. All right, let's add a few more variables in here. Again, just put these numerator pieces over the denominator. So let's split this into 6m cubed and 30m to the 4th, and put them both over 2m cubed. And then let's simplify. M cubed divided by m cubed, those just cancel out. They give you a 1. And 6 divided by 2 is 3. On this one, 30 divided by 2 is 15. And if I have 4 m's up top and 3 m's on the bottom, all of them cancel out except for 1. Or another way to think about that is 4 minus 3 gives you 1 m. Or you could think about it as 1, 2, 3, 4 m's on the top and 1, 2, 3 m's on the bottom. You can cancel 1, 2, 3 of them, but you, whoops. You cancel 3 of them, but you still have 1 m left on the top. So this is my final answer on that one. Okay, still going here. Let's try this one. I'm going to put 40x squared y to the 5th, and oh, that's a minus. Minus 16 x cubed y squared. Sorry for the plus minus, but plus adding a negative is the same thing as subtracting anyway, so. And all over 4x y squared. And now let's see what we can cancel. 40 divided by 4 is 10. X squared, cancel out one of those x's, leaves you with just 1x. And if you have 5 y's but cancel out 2 of them, you're left with 3. Again, I'm just subtracting here. 5 minus 2 is 3. 2 minus 1 is 1. Let's make this back into a minus. 16 over 4 is 4. 3 x's, cancel out one of them, leaves you x squared. And then these will just cancel completely. 2 minus 2 is a 0. This is my final answer on that one. All right. I do want to mention, if you ever have a denominator that's like, let's say this was plus 1. You can't ever split up, like you may be tempted to put this over that, and then put this over the 1, and you can't do that. If you're going to split it up, you have to put it over the entire denominator. So if I did want to split it up, I'd have to put the plus 1 and plus 1 in both the denominators. So just be careful of that if you ever have more than one term on the bottom. You can't split up the denominator like you can the numerator.